Good afternoon, everyone. I hope we're all in the same time zone. My name is Elizabeth Mwashuma. I don't know if you'll have a chance to do a quick round of introductions just to get a sense of everyone in the meeting room. Is that okay, Favor?
Yes, that's okay. That's okay.
Okay. So maybe just to make it quick, I'll just say a name and then you just come in, just introduce yourself briefly, your name and where you're joining us from, and probably also just a little bit about yourself. Okay, so Stephen Gitahi.
Hi, everyone.
Yourself. Yes.
So my name is Stephen Gitahi from iLab Africa Research and Innovation Center, Strathmore University. I think part of the organizing team.
Okay, thank you.
Thank you.
Alex Watila. Do I think I know Alex Watila?
Good afternoon. I'm Alex Watila from IEEE Kenya. Welcome to the training. Thank you.
Thank you. Douglas Rono?
Hi, my name is Douglas and I'm a participant.
Joining us from which organization?
Startup. Called
Startup. Okay,
yes.
Thank you. Evelyn Otieno?
Good afternoon. I'm Evelyn Otieno from Gearbox, Kenya. Thank you.
Thank you. Invincible J?
Yes, my name is Divinalis Hamasi. I'm an innovator.
Thank you. Okay, Lorraine Udeo?
Hi, my name is Lorraine Mudu from University of Nairobi. Yes.
Thank you. Maxwell Washira?
Hi guys, my name is Washira Mwangi. I'm a mechatronics engineer. I'm also from Gearbox, Kenya.
Thank you. Tom Kinyanjui?
Hi, I'm Tom, joining you from Eurolabs Innovation Hub. Basically, what we do is AI for health. Thanks a lot.
Thank you. And lastly, Ndirangu Buru? I don't think Ndirangu's microphone has connected to the call. All right, so thank you all for introducing yourselves. My name again is Elizabeth Mwashuma. I work, I'm a member of IEEE, but I work as a consultant mostly. I do system design, system analysis, quality assurance, and also MIS training. I mostly consult for a number of organizations, and I mostly develop or design, actually. My work is design, entirely design. I don't touch any bit on development. But in the design processes and QA processes, a lot of documentation is what I do. I do a lot of documentation. I meet with the clients. I have stakeholder consultations. I come up with documents which you're going to refer to in a few seconds. And I'm looking forward to this discussion. In terms of my background, my first specialty degree was in computer science, and then I did a master's in applied computing in Nairobi, University of Nairobi, and I'm currently a PhD candidate for information systems, studying information systems, a doctorate degree in information systems. Okay, so I have prepared a presentation. I know we have a very short, about 40 minutes maybe, for our discussion today. My presentation is just 5 slides. Let me know once you're able to see my screen.
Yes, we can see your screen. Thank you.
Okay, and then I'm not able to see participants. In case there are any questions or hands raised, maybe I can have Favor just bring that to my attention. Is that okay?
Yes, that's okay.
All right, so I'll try and make this session as interactive as possible, and please unmute yourselves and just give me an overview of what are some of the phases? So let me just first of all begin by saying that, if you're looking at system documentation, then you're looking at the entire life cycle of a system development. So the standard SDLC, the software development life cycle approach, and the various documentations that are required across those cycles. So I just want to get an indication from everyone in the room, just what phases do we know within this SDLC? I should just a quick warm up. The phases in the software development life cycle, you can just shout, unmute yourself and mention a phase. Where do we begin from?
Requirements engineering.
Requirements engineering. Anyone else? The phases in the software development life cycle. Don't be shy, just unmute yourself. I know you know these things. There's nothing new. Anyone else? Okay, that's okay. Fine. So I'll just proceed my presentation then. So from practice, I find these 6 phases to be very key for systems development lifecycle approach. There's the inception phase, the system analysis and design phase, where you're going to now do the requirements gathering and requirements engineering. We have the development phase, where the actual product development is conducted. We have a QA phase, where the tests are conducted, training and documentation, and then finally implementation and research. So I find these as the key 6 distinct phases in systems development lifecycle approach. Again, from practice, you may find inception phase being combined with system analysis phase. Other approaches would combine development and QA. Other approaches would combine training and implementation. But I find these 6 phases quite distinct in the kind of work that I've done and the kind of system development lifecycle approach that has been used in system development and design work conducted. So my next slide looks at these phases in detail and focusing basically on the outputs. I hope you have a full, I hope you're able to see the full screen. So in this table on the left side, I have the phases, the list of phases, and then across the document or across the table, we have the lead, the outputs across the phases. So it's documents across the phases, and then what is the content of these documents, and then lastly, tools and other information that I thought will be useful for this discussion. Now let me time myself. We're now at 14:21, so I'll stop at about 14:40. Now, in the inception phase, in this phase, it's a very critical phase because it's the team leader who now leads this phase, and the critical outputs in this phase, the inception report. Now, the contents of the inception report is your methodology, what software, what SDLC approach are you using? Are you going to use Agile? Are you going to use waterfall, prototyping? So whatever methodology you're going to use to develop the software, the entire lifecycle approach is what you state in the methodology section. You state your work plan, which is usually a Gantt chart and like. You state your team composition, who your team is composed of, that is going to implement the project. You conduct any risk assessment and you provide a matrix to say, these are the risks you've identified, this is how you're going to mitigate the risks. And you also assess the level of impact in case this risk occurs. And then a very critical part is the dependencies. As a team about to design a system, there are certain dependencies that may influence your work. I'll give an example. If one of your dependencies is, if you're looking to integrate a couple of systems for your system to operate, then that becomes a dependency. Acquisition of either API documentation and the like, that becomes a dependency, and that needs to be stated. And it doesn't end there. You have to state your dependency, and you have to recommend a way of going about addressing this dependency. So that needs to be clearly stated out in the Inception report. And then shadowing teams. So sometimes you may find as you interact with various clients, they may not have the full capacity to work with you as you're developing a solution. So sometimes they may require shadowing teams. So the client proposes 2 or 3 staff who are going to work with you as you're developing the software or the system. So you'll probably have a system analyst on their end joining your team, a system developer from their end joining the team, a QA, a training. So depending on the client, sometimes I find shadowing helps, especially when it comes to training. When you've had a good amount of their team members also part of this entire process, it becomes very much easier. Now, I understand there are two types of approaches we apply here. There are those who are developing systems that a client has requested. So a client has come to you and requested that they want system X to be developed, and you go ahead and develop the system. And then there are those who are entrepreneurial and will come up with a system, and also now you only end up with a finished product and then engage with the user. So shadowing teams may apply only when you have been engaged, and then you begin this whole process with the client. Now, in the systems analysis and design phase, this phase I find the most critical phase in software development, because the entire scope of what you're going to develop and the final product is totally dependent on this system analysis and design phase. Okay, a big chunk of it is dependent on this system analysis and design phase, because you are defining what the system is going to do. You're describing your users, and you're going to speak to it in a short while. And I find this is one of the most important phases in software development lifecycle approach. This is led by a systems analyst as a specialist. And then in terms of the outputs, we have two documents that are really important to be produced in this stage. This is the software requirement specification document, the SRS document, and the software design document, so SDS or SDD, software design document. Okay, in the SRS document, there are 7 distinct items that you must include in the SRS document. So first, let's go through the user requirements analysis. User requirement analysis is where you interact with your users. You want to find out what are their needs. But I always scope this section. I always have a matrix. And in this user requirements analysis section, I specify the user type. So if you're maybe you want to develop a software or a system that is going to register households, for instance. So in this case, you're probably going to have an enumerator, a supervisor, someone who approves and the like. So let's use these two user types, enumerator and supervisor. So if you when you're doing a user requirements analysis, your first user identified is an enumerator. You have to identify, so after identifying the user type, you have to identify the jurisdiction. Are they based at, is it at the administrative level? So maybe an enumerator is based at the location level, a supervisor is based at the sub-county level. So that level of hierarchy has to be defined. Also, you have to define, or sometimes it could be based on tasks. So maybe an enumerator, if you're looking at a hospital setup, for instance, maybe the enumerator is at the registration desk. So you have to specify the jurisdiction in which this user is going to be using the system. Another thing, you have to specify the interface they're going to use. Are they going to use the web interface? Are they going to use a mobile application? You have to specify that for each user that you identify. You also have to specify the devices they're going to use. Are they going to use mobile phone, a tablet, a laptop, a desktop? You just need to specify and understand what each user is going to interact with the system. You also have to understand from this user requirements analysis the number of users that are going to interact. This is important because as we get to the non-functional requirements, there's a very important aspect called performance, where you want to assess performance of the system. And performance is also gauged by number of concurrent users accessing your system. So in this stage, you want to understand how many users in this user group are going to be accessing the system. Another item is you have to identify permissions. What permissions are you assigning to this user, or the various user groups that you're defining in this user requirements analysis? And then lastly, for each user, you define their needs. So if it's a numerator, the need is to capture household data. The other need would be to edit, maybe to edit data captured or submit data captured. And those are some of the key needs of this user rather. So once you're done with the user requirements analysis and you have a matrix showing all this, the different users, the jurisdiction, the interface they're going to use, the device they're going to use, the number of users, the permissions, and their needs. Now you come to a very critical part where you define now in a general term what are the key user needs, And here you specify, you highlight, given that you're going to come up with maybe even, depending on the system, you probably come up with about 7 to 8 users of the system, from business users who are just interested in analytics and reporting function, to those who are going to review, approve, all those users. You now come up with a highlight of maybe about 7 points of the key user needs of this system. Now, this key user needs is what informs your functional specifications. Your functional specifications is now a whole chapter that defines what functions this system is going to perform. As you're detailing out your functional specifications, you need to highlight for each function. So for instance, we say this user is an enumerator and they're required to register a household. So at this point then, as an analyst, they will now define a registration module. And this module will have, for you to define your module, you have to have business process maps, where you say a user, say an enumerator will log into the system, access the registration module, register a household using certain forms, and then the next user is going to be a supervisor who approves or edits or accepts the record, and where they reject the record, what happens to that? So the business process map maps out how the data will be flowing for that particular module. So the functional specification section will detail out all the functional areas of the system, of your system, and will also contain the business process maps, which show, it's a visual, they visually present how data will be flowing across the system. I can provide some images maybe towards the end of this presentation. Now, once you detail out your functional specification, which will include, in our case, registration module, maybe a data analytics and reporting module where business users can come and interact. If there are any other functional areas, say payments, you'll have a payments module, it will have its own business process maps. You'll specify for this module what each user is going to interact with this module. So you specify all of that. Yes, thank you so much for highlighting that. You specify all of that in the functional specification section. And the next equally important part of the SRS document is the non-functional requirements. Now, this is usually the heaviest in my opinion, and quite the selling point. This is what you can use to sell your product, because you're actually stipulating the quality aspects of your system. And we talk about quality aspects, you're talking about reliability, you're talking about availability, you're talking about maintainability, security aspects, data protection, you're talking about, so all these aspects of a system that are not about the functional, how the system is working, but rather what enables the system to work. And I find that these non-functional requirements is what now really sells your system, because you also set out your performance. You say, my system is able to support up to about 1,000 concurrent users per session in any time, at any given time. So you stipulate what your performance, and I'll highlight some of these non-functional requirements in a short while. And then now the next part of the SRS is the recommended hardware and software environment. So after you've designed your system, you have stipulated your functional specifications, you say in the non-functional requirements that you're going to ensure that it's going to be a secure system. You're talking about levels of encryption at the database level. You're going to encrypt personal identifying data. So when you specify those things in the non-functional requirements, what environment will enable you to actually deploy this system? So you recommend what hardware and what software the client needs to have in order for your system to perform optimally. So this is the recommended hardware and software environment that you now present. And usually you would provide your specification recommendations for a production environment. Your primary server, what should it be? What size should it have? What processor should it have? What memory should it have? Yeah, if one of your recommendations is you provide 100% availability or 99% availability, then what backup and redundancy are you recommending? Is there a backup solution you're recommending they need to install? Is there an environment you're proposing for for disaster recovery? So All of that you present in this, you recommend to your client, as this is the hardware and software environment I want you to provide for my system to function at 100%. And then lastly, you have recommendations. If there's any recommendations you want to make around training, around devices, around this recommended hardware, you can present them here. And then lastly, the annex, which involves the documents. So the forms that are going to be digitized have 7 minutes. Okay, you'll include them in this annex section. Now, the other document, very critical, the system analysis and design phase, is the software design document. In this document, you specify your integration architecture, you specify your database models and schema. So in this case, if you are either using analytical processing, so if you're using a data warehouse, you use the OLAP schema. If it's a transactional processing system or business processing system, then you use the OLTP schema. In terms of the UI, you provide the user interface design for both the public interface and the private interface. And then in terms of interaction, you now model how the entire system, the entire architecture is going to all the modules are interacting with each other, how the data is getting into the database, you know, how every component of your system is interacting. And here you use UML modeling tools such as Archimate. I highlight it here. Archimate tool is used for UML modeling. And some of the architecture frameworks recommended, I use Toga, for instance, and it specifies your business users, how the application responds to the needs of the business users, how your data is flowing across the system, and then what technology, what database, what security environment is. So you're bringing everything together in terms of the application, the software requirements side and the software design side, all comes together into the architecture that you're proposing. And then lastly, you also have to include the deployment architecture, which says, so you have designed the system, how am I going to deploy it? Are you going to be deploying it in a virtualized environment? What hypervisor are you suggesting? Are you going to have load balancers? At what point are you having load balancers? What network components, switches, and the routers? You know, so you define your deployment architecture as well. And then lastly, you have annex of all the API documentations. Maybe if you're integrating in several systems, you can have the API documentation stored within the annex document. I always say simply when it comes to API documentation, the person hosting the data is the one providing the API documentation. So if you're going to interact with, say, Safaricom, for instance, and you want to validate some data points, such as mobile phone numbers, they host that platform for verification. So you request for the API documentation to enable you to integrate the two systems. All right, and these are the last cell, let me say cell. I recommend Lucidchart is what the tool I use for business process maps. And then IEEE has some documents, standard documents around the SRS and SDS templates. And then lastly, it's very important to go through a requirements validation process, especially where your client is the one who's requested for this solution. You must go through a requirements validation process for them to confirm that the requirements specified in the SRS and the design document are indeed what they intended the system to have. And this is important before you move the systems development phase. Now, I cannot talk so much about system development because I'm not a developer. I just know, you know, the leads are the senior developer, junior developer, mobile application developer. You define your coding structure and environment, and then you get to now determine the level of let me say microservices. If you're going to use microservices or web services, then you're going to define here how that is going to be implemented. Allow me not to talk too much about this section. Now, the QA section or the QA phase is another phase that has a number of documentation. Specifically, the QA specialist is the lead in this phase, and the key output here is the quality assurance report. Now, this report is usually developed in layers. So you first have the developers conducting some tests, unit tests, component tests, integration tests. So once this is finalized and you have a system ready for the QA specialist to begin testing, then you run a couple of internal QA tests. I always call it, you have an internal QA test where the QA specialist will define the test cases, will define the testing environment to be used to support the testing, and then and they'll be testing particular aspects of the system. One of the aspects is the functional tests. Remember, as you're defining your SRS and SDD document, everything you define in this document should be testable, especially in the SRS document. Your non-functional requirements should be testable. Your functional requirements should be testable. Now, when it comes to performance testing, you're testing whether you're doing stress testing, you're doing load testing, and you're confirming that the system can actually support the number of users that you're recommending. Yeah. And the QA specialist will run all these tests. And then once they run the tests, you provide feedback to the developers, and the system is ready for now external QA, where now you're inviting the clients for user acceptance testing. You provide the test cases again, the test plan, the documentation around it, and then you run the tests with the user or the client. Now, it is very important at this point to also conduct a system usability scale. It's a usability test, and there's a system usability scale readily available online that it's important to get the user's feedback around the usability of the system at this point. Now, the fourth layer of the QA process is the post-UAT walkthrough. So once you're done with the UAT, you probably find additional feedback coming in from the test, the UAT process. And it's at this point where you capture the feedback you received from the clients and you document it, and then you get it back to the developers to improve the code of the system. And then once the developers confirm that they've addressed the comments raised in the UAT, then you have a post-UAT walkthrough where you confirm to the client that these are the issues you raised and they've been addressed. And then once that's finalized, you produce your final QA report. At this point, it's very critical that the systems analyst or the QA specialist ensures that there's no new requirements coming in at this stage, because it's very easy for clients to include new requirements or requests for additional components that are not envisaged. And that's why the requirement validation process is very key in the system analysis and design phase. Okay, so you're done with the QA assurance, quality assurance, you have your quality assurance report. Once that's signed off, then you can now proceed to the training and documentation. The documents required here is the training checklist, a user guide, and summary of system processes, because during training, you're also likely to get new users who've never interacted with the system, even at the design phase, and now you're coming up for training, and they have to understand how the system is performing. So a summary of the system processes is very key. At this stage also, you begin to build up your FAQs, because during training, there are a number of questions that keep coming up, and that helps you to build your frequently asked questions. And then lastly, our implementation and research phase, which is one of my favorite phases, is where you now begin to, so from implementation, you're providing the source codes, you're updating all the documents, SRS, SDD, depending on the methodology you use, they may require to be updated, and then also coming up with the FAQs. From a research perspective, you're assessing the readiness. You first assess the readiness of the system before deployment, and then you assess usability, performance of the system, utilization of the system, perceptions, usage as the system is being deployed. And in a nutshell, that sort of summarizes the kind of documentation that I see useful as within the software development lifecycle approach. Okay, I want to take us through, I just want to show one slide that just sums up in a nutshell the entire QA process, but I'm sure you have this information. I just wanted to bring out the various types of tests. There are manual tests, automated tests, and some tools that you can use to conduct the testing. And these results of all the QA tests must be included in the quality assurance report. Now, in terms of the non-functional requirements, allow me to quickly share. Okay. I don't know whether you're able to now see a Word document.
Not yet, we are not able.
PowerPoint slide.
Okay, let me just stop share and then I share again.
All right, thanks.
How about now?
Yes, we can see it. Thanks.
Yeah, okay. So this document just outlines some of the non-functional requirements I always have in mind as I'm defining the software, the non-functional requirements section of an SRS document. So one, you have to define your availability. And availability means what is the likelihood of the system being accessible to the users at any given point. So good practice is to ensure that your system is available within critical business working hours or critical business hours. So between 8 or 7, depending with the client's operating hours, between 8 and 5, and then ensure that it's still available outside of the critical business working hours. In terms of reliability, you're checking. It's a quality attribute that specifies how a system or its elements will run without a failure within a given amount of time. So you specify your reliability aspect of the system. Maintainability, you're saying, for instance, here 75% maintainability for 24 hours means that there's a 75% chance the issues identified will be fixed in 24 hours. So you state how maintenance, the maintenance aspects of the system. Obtain indication of the expectation of the customer during analysis phase. So it's important to indicate, actually, most of these non-functional requirements, you have to engage the client to understand also if they have their own metrics within the organization that determine some of these non-functional requirements. When it comes to security, how are you protecting the system against malware, attacks, unauthorized access? So do you have encryptions for network connections, encryption for personal identifying data stored in the database? So you specify that. If there's going to be any APIs being accessed, are you going to use token-based APIs? What kind of encryption are you using? Are you going to enforce password expiration rule, account deactivation, disabling account? So you specify how it's secure. When you say people, when you talk about your system is secure, how have you enabled it to be secure? And remember that this will be tested during the QA phase. In terms of performance, you define how fast the system responds to a user's action, how much a user must wait before the target operation occurs. Again, you also have to state what type of connection is required to guarantee 99% uptime. The response time for accessing your system, you define what response time is going to have. You also define your current users, daily load capacity, and some of these figures can also be confirmed during the performance tests in the QA phase. Extensibility, you're checking to what extent your system can integrate with other systems. Either those that directly direct integration, so systems that your system depends on 100%. So I'll give an example. Sometimes you develop systems integrating for purposes of obtaining beneficiary information, so information purposes of obtaining information, or for purposes of validating information. I'll give an example. Once I designed a system where it was a data warehouse, and they wanted a function for obtaining all the beneficiary data across various ministry databases. And in this case, therefore, we were integrating to receive beneficiary information. And you also, within that project, we were required to design a verification, a validation point where for each, so for instance, if I give my ID number, we can validate that this is actually a Kenyan. So there are various reasons why you want to integrate. You can also integrate for purposes of data analytics and reporting. So you state to what extent your system is extensible. You give your sizing information. So from the performance, so performance will also you also state the kind of data that is going to be stored in your system. If you're registering households, for instance, and for each household, first of all, you're going to register 10,000 households. Each household has 7 members. Each member of a household will upload their ID, their photo, and will also upload maybe a birth certificate. So you already specify what size you expect these uploads to have, and then you multiply by the number of households you're anticipating to register. That helps you to understand your sizing, what sizing you're going to have for your system. So you specify there. Again, interoperability, the hosting platform, you specify if you're going to use open solutions or proprietary solution, if you're going to host your environment in open source platforms or Ubuntu, MySQL for your database, you specify here. You can also specify remote desktop administration, how are people going to be able to access your system remotely. Software licenses, if you're going to deploy, what server environment are you going to deploy a solution? What database environment are you going to deploy a solution? Are there any file servers you're going to use? Any virtualization environment, backup solution? So you specify what licenses will be required for you to operate your system, and the file solution as well. And then very critical here, I wanted to mention the data protection. You have to ensure that your system protects the data of those whom you have collected data for. So how are you aligning yourself to best practices around GPDR, so Global Data Protection Regulations? I think another word for G. And also existing government data protection acts or bills, and also domain level data protection. So for instance, the Ministry of Health would have their own domain level data protection laws or guidelines. Actually, those are guidelines when it comes to domain level. So you also specify and confirm that you're aligning to these data protection requirements. When it comes to accessibility, you're confirming that your system can also support people with either visually impaired or hearing impaired. So how best does your system support this? There are ways, I think, I'm able to provide some pointers on this, but you also specify to what extent your system is accessible to persons with disability of any kind. User interface, we talked about this. You specify your external, your public-facing interface and your internal-facing interface. It's a public access portal. You specify your client-level hardware and devices. So if your client is supposed to access this system for user, what environment should they be in? What device should they use? If you're suggesting that they use Android tablets, what version of Android are you recommending for them to use? So those are some of the client level hardware devices that you're recommending to your client to have in order for the system to perform optimally. Again, server level hardware, you're specifying, your antivirus, firewall, switches, rackets, cabinets, server PC, the production environment, what should it have? If you're going to implement in a virtualized environment, what specifications are you giving for the hypervisor? Any recommendations you're providing? If there are any policy recommendations you want to make, okay, policy may not be the right word, but any documentation, internal policy documents that you're recommending, should they have a license management policy, archiving policy, backup strategy? So this is also enabling you to ensure that your system, once deployed, it's going to be 100%, and you stipulate what needs to be in these documents as well. Again, virtualized environment, you state your production environment, what should be in it, the testing environment, the development environment. And then lastly, regarding usability, you're assessing to what extent a user is able to interact with the system. And here I recommend using system usability scale during the UAT. I'll pause here for questions and reactions. I know I've overshot my time, but I'll pause here for questions. Back to you, Favor.
Wow, thank you very much. You actually didn't overshoot your time because we had a provision until about 3 p.m. For the presentations, etc. For the presentation, so that's you're actually, you've saved time. So in case there's anything else you'd also still want to share, please feel free. But yeah, thank you. That was a really insightful session. Because when a lot of the times when we talk about system design, we've never looked at it from an implementation standpoint, like say the scenario you're describing, especially in the startup space. Like a lot of the time you start from the problem that the user you've identified is facing, and you model your solution around solving that problem and the user environment of your user. So if it's IoT, you're looking at where's your user located, what devices and technology access do they have, but never from a system design standpoint. So this is really insightful. So thank you very much. I think we could move on to some questions. Might there be any questions? You could just take a round. Just feel free, just raise your hand and you can proceed with questions.
Okay, maybe even before the questions start coming in, you just mentioned something, Peva, and throughout also my design of systems, we find it a best practice during software requirement specification when you're detailing out the functional areas of your system to leave out completely the technology that is going to be used. There seems to be some background noise from your Peva.
Oh, sorry, let me.
Yes, I was saying that we find it best practice whenever you're defining the functional specifications of a system to leave completely the mention of the technology you're going to use. At the software requirement specification stage, you're just identifying the functionality of the system. How you're going to implement the system should be defined in the design stage. When you're now saying that you're going to use IoT, you're going to use AI, you're going to use machine learning. All these technologies that you're defining should only come in the design phase when you're doing the software design document and not at the SRS level. At the SRS, you're just trying to specify who are your users, what are their needs, how is the system going to function? I mean, how should the system function, and also the non-functional requirements. But when it comes to defining the technology, you're going to use what technology environment you're going to implement this solution in, that needs to go in the design document. And that's why also the APIs are in the design document and not in the requirement specification document. But I just also give that point on. But I now welcome any questions that anyone may have. Over.
Hello. Yeah, mine is not really a question, but it's a comment. I found the presentation very interesting because from my end as an innovator, I tend to do both the development and the documentation. So more often than not, I tend to write everything, to write the technology and all that in my documentation. But I think the presentation has been very insightful, and I think moving forward, I'll do better. Thank you.
Thank you, you're most welcome. I saw a comment, a request to share the presentation. Yes, I'll share the presentation, I think, with Favor and team, the organizing team, and they should be able to share with all of you. Over.
Maybe we, as some people think through some questions, you could share maybe your experience. Have you worked with IoT-based projects or AI-based projects? And from a system design and documentation standpoint, what is your experience like? And what insights could you share from that?
Thanks. Now, I haven't worked directly with AI and ML solutions. There's one project, I think we wanted to go that way, and it was going to be in the domain of healthcare. There's a series of data available, I mean, a vast amount of data available for a certain project, and they're trying to understand how best they can learn from the data that is coming in going forward, and also from the data that's already existing. I think we only went to the level of concept design, but we didn't move towards the point at implementation or even at the design stage. We didn't get to that point. So I'd be interested in learning actually from everyone here how the experience has been around AI projects and that like. Over.
Okay, great. Maybe that question we could jump to Maxwell, because I know you've worked a lot with IoT-based projects, especially your background in mechatronic engineering. So would you like to jump in on that question?
Okay, Favor. So I'll respond to that, but I think I have a question for Elizabeth. So first of all, thank you for the nice presentation. And this is my question. So you want to do SDLC for a startup. I'm assuming like the startup is not financially stable to hire a system analyst, a QA analyst, a couple of developers, system developers. So like, how do you like try and ensure you do SDLC on a budget? because yeah, probably you might not be in a position to get all those people to. I think you get my question. Yeah.
Yes, I do get your question, and that happens. That happens when you don't have enough resources to have a robust team to handle everything. So what I would recommend is the inception phase is the team leader, but also the team leader can perform system analysis and design. Because the team leader should be able to, as much as they are providing oversight to the entire project, the team leader can also be the systems analyst, as long as you have, you know what you need to define in your software requirement specification document and software design document. The team leader can also be the systems analyst. Now, the developers will just be the developers, because the developers, they have a specific set of skills. For the QA specialists, if you do not have a QA specialist, the systems analyst can perform that role. So in essence, also the team leader can perform that role. The QA can then be performed by either the QA specialist or the systems analyst or the team leader. When it comes to training and documentation, again, if you don't have the documentation specialist or the systems analyst or the QA specialist, if you don't have a documentation specialist, then you can have the team leader. The systems analyst also plays a very important role here, because this person has been interacting with these users from the beginning and will probably interact with them when they're doing the QA tests. So at the point at which you're training now the users, becomes a really easy touch point for them, because you've been understanding their needs. So it's very easy for you to also conduct the training of the MIS. So again, in this stage, you can have the systems analyst or the team leader or the QA specialist conducting the training. Then it comes to implementation, again, the team leader or the team leader especially can run the implementation of the system analyst. So you see how, given limited resources, I think the two key resources you need to have is the systems analyst, who could also serve as your team leader and your QA, and your developer. I think those two must have those two. I'm very particular about not having the developer performing the QA, because you may be biased unless you really had a very robust systems analysis phase. If you really had a really robust system analysis phase, then you may, as a developer, you may run the QA session, but I highly advise not. I don't know what your opinions are. I mean, the rest in the call. What has been your opinion on one person implementing? I know as a startup, it's very likely to have one person implementing everything, but also looking at time required to perform all these aspects adequately. And again, I must say that the SRS and SDD documents, and even the architecture framework suggested, are only guidelines. They're supposed to guide you to come up with a better system and a better project management, per se, of the entire project. But even as you're developing the system, sometimes even you read functional requirement specification section that are really, very, they don't contain a lot of information. But if you have the time, if you have the resources, it's important to be as specific as possible, because at this point, remember, I think the beginning point you have to remember is this what will help you to sell your system, your product. At the end of the day, with this documentation, it becomes very easy for you to put your product in the market, and it's very distinct. You're able to say who this product is targeted for. So I think you must, in a sense, try and bargain in terms of to what extent you can come up with all these documents, follow the SDLC process to the later, knowing in hand that you have issues around resources that you have to be alive to. And but I'd like to hear from the team if you've had experiences, one person implementing all of these roles, what her experience has been, how the outcome was at the end. And I'm also interested to know whether the team feels having at least two persons, so either the systems analyst or the developer, being the two key resources of an entire, at least having two, the analyst and the developer, to implement the entire. Maybe your thoughts on that, team. Over.
Hi, Elizabeth.
Yes, hello.
So Stephen here again from ILAB, and I think I would concur with what you've just mentioned. Coming from or having worked on different IoT projects, I've seen the same. You might hear people saying an IoT project that is that has a software developer, a hardware developer, a project manager, a project coordinator. So there are many roles that have to be played, especially if the project is complex. But as you've also mentioned, you can minimize all this to just 2 people: someone to focus on the system implementation, and someone else to be the bridge between the person who is developing and the client on the other side. Yeah.
Good, thanks for that feedback. Any other comment or question? I also must say that the team leader here also serves as the project manager. So you're also managing the entire project altogether. So the smaller the team, the more the roles. And it's unfortunate as a startup, you have to take up so many roles so that as you grow, then you can bring in more specialists, have more people specific to various phases. But I understand that during this, as a setup, you probably have only 2, sometimes even just 1 person performing several roles. Okay, I'm just going through the comments. All right. Tom, I don't know whether your question is to me or to the organizing team.
Should be to the organizing team. Should be.
Okay. Favor, do you want to come in?
Yeah, but maybe as Favor comes in, I would give a little bit of what you asked about. So we are currently a startup that's doing AI.
Mm-hmm.
Basically, what you're doing, you're building models to identify diseases on chest X-rays, on ultrasound using breast pathologies. So in real time, that is. And
Mm-hmm.
on chest, we're able to identify over 20 pathologies, which include COVID-19, pneumonia, TB, cardiomegaly, pleural effusion, and so on and so on. So basically, we are using deep learning to be able to identify diseases in real time. Because especially in Africa, it will take you quite some time before you get your lab results. So basically in the setup, we are a startup. We had to do everything. Practically, I'm a machine learning engineer. We are 2 machine learning engineers in the team and software developer, but we did the entire thing from development to the deployment. So I think it's not that hard. You can handle it for the start, and with time, everything will be better and better.
Good, thanks for that context. I'm glad to hear machine learning for HI, for health informatics and health in general. One of my areas of interest has also been health informatics, but slowly moved into social protection domain. But happy to hear how ML and deep learning particularly is being used in that respect. I see a question from Evelyn. What advice could you give to upcoming systems analysts? I think in a nutshell, I would say documentation is really key. Documentation is actually the most, and system analysis and design phase is really one of the very core aspects of software development. And as a systems analyst, your role is to really seek out to understand what the user really wants. And you'll also come to a point where you have to negotiate. Sometimes a user comes up with very ridiculous requests or requirements or specifications. And you have to learn the art of negotiating for your developers, because sometimes you may be required to develop a system that is, in terms of scope, in terms of time, may not be achievable. I'll give you an example. There's one client who wanted us to have data transferred between devices via Bluetooth in the field at the end of every day between the enumerators and the supervisors. And the supervisors are supposed to still go to each household. So some requirements may sound very ambiguous, and it's up to your role as a systems analyst to clarify and make things as simple as possible. And where a client feels that they want to have a bucket list, you have to be very upfront about it, definitely careful, but then looking at it from an aspect of scope and timelines and viability of the requirements being requested. So there's an aspect of negotiation and that you need to have, and prioritization. You have to negotiate and prioritize for the requirements that you're going to receive. But as much as possible, engage all the stakeholders that are going to interact with the system. Sometimes during the validation process is also very key. In the validation workshops, you will now take all the users. So of course, after you develop the SRS document, you've shared it with the clients, they've given you feedback, they've confirmed that this is in line with what they wanted. During the requirements validation workshop, now you take them through the system again. And this has to be like the users of the system and external parties, because usually a system may be utilized by more than the people that you've interacted with. So this is where you bring in, if there's any integration that is occurring with any other external system, you also bring them on board. So they also understand the system. The validation workshop is really key, because once you have gone through the validation workshop, it confirms that whatever is in the document can now proceed to development. Because also when you work with development and now with the era of time-based contracts, a developer, someone would hire a developer for maybe 10 days. And in those 10 days, they're very critical, they're very specific things they need to do. So when those 10 days elapse and the client comes back and tells you, no, I want item X to be added, and you hadn't considered that means you're having scope creep. You're also going to incur more costs. So the system analyst, when it comes to designing the system and understanding the needs of a user, you have to be alert to the process. If there are any systems you're going to integrate with, understand the types.
Sorry, Elizabeth, are you there? I'm not sure if, can you guys hear Elizabeth?
I think we've lost her.
Maybe her connection dropped.
Yeah.
Sorry, we can give her a minute to rejoin. Meanwhile, might there be any other questions as well? You could also type them in the chat, or raise them directly as well. I think she's rejoining. Yeah. Maybe Stephen, because I know you've worked in the IoT space, you've trained startups, incubated startups in the IoT space.
Sorry, Favor. I see someone says they can hear her. I'm not sure. Maybe it's you and I that are out of the meeting.
Oh, wow.
Actually, I also can't hear her.
Oh,
So probably the three of us again are out of the meeting.
Maybe the four of us.
So can't hear. We are many.
all right. I think it was a typo.
Okay, that's okay.
Yeah.
Yeah. So maybe Stephen, you could share a bit about your experience in terms of system design and documentation, having worked with startups in the IoT space, both in a personal capacity and also in a professional capacity.
All right. Well, most of what she's covered is actually very true. I concur almost everything she says. And this last part, I think she was about to even disseminate some more knowledge in terms of, yes, the solution might be very, very nice, but if you're not able to, number one, present it, and by presenting, you have to be able to send out a proposal that says, guys, this is what we've built, before they even give you a chance to come and present to us your solution. So I do agree, presentation is very, very important, and also documentation in terms of putting out your product. For us, us that we are here, most of you guys, because your context is the context of a startup, so you'll be forced to if you're working alone or if you're working with someone, you'll be forced to be able to divide the tasks and work very quickly, because you'll realize when I take a proposal that is 50 pages or 20 pages, I won't necessarily go through it. So it's page by page. So I will have certain elements that I'm looking at. So for example, what are you trying to solve? Is that clear from the word go? How do you want to solve that? And maybe what do you want from me? So if it's a proposal and you're asking me to partner with me, then the question would be, what are you doing? How are you doing it? And what do you want from my side? So if your documentation can capture that very briefly, maybe in form of an abstract at the start, before you even go to the nitty-gritties of we've tested, we've tested the solution, this is the kind of response we're getting from the users, what do the different units do, how do they work, so in a very high level. So that's what someone who is sort of skimming through these proposals would want to look at. So if that is captured, of course, once that's only to sort of filter through. If I have 100 proposals and I want to go through 20, I would look at the abstracts or the summaries. So the summary is almost the same as abstract. So I look at that to be able to filter out the top 20. And then from there, I can now go through the 20 page by page to see if the other nitty-gritties that Esther has given into details are there. How secure is your system? How easy is it for users to use it? Have you done prototypes? Have you simulated how the system is going to work? Blah blah blah. So I think that would be a point that I would want to maybe pass, which will also come when you're trying to present your project. So you've done your project, you've done your project documentation, but you still need some slides to be able to present your work. And you've seen what Elizabeth has done here, 5 slides, but very concrete content. We've actually understood what she's presented without necessarily going through 101 slides. So the slides should also capture those key elements about your project, so that once you've been able to attract these people, then they can go through the documentation page by page. Yeah, so I see Elizabeth is back. Maybe I give it back to her first.
Yeah, sorry, I got dropped off. I don't know what happened to my network. But I hope I answered Evelyn's question on best practices as systems analysts. Evelyn?
Yeah, you did. Thank you.
Okay, thanks.
Thank you. Maybe just jumping back to the question from Tom Kinyajui. You had mentioned that he missed the introduction part of the IoT and AI challenge. So mainly it's a challenge for university students, graduates, startups, and young STEM students, guys who've just finished high school or are near their fourth form, A levels, or IB level, with the academics, so that these are people who are innovators by heart, or by training, or by experience, or by exposure. And it's a platform that's meant to give them a chance to explore, collaborate, and implement projects that they've been researching on and ideas that they've had. So you have lots of the time, like the startups or teams that participate are spread out. So some are later stage, using, say, the example Stephen just gave. They've gone through, prototyping. They've not only simulated, they have documentations, they have an MVP, they've tested with users in the market, they've sold some, IoT devices, if it's IoT, or if it's AI, they have subscriptions on their system, if it's a software as a service, or it's API based, whichever the approach. Some have tested, so it's a broad. Usually, the teams or the people that are accepted are not. It's not stringent or strict. So what happens is now towards the end, which in this case would be around the 28th of August, the teams will be sent out, a submission link will be sent out to you this coming week, where you'll be able to submit your projects, whether it's in the form of a deck. So yes, it's a broad approach for startups and teams and innovators. So you could be in university, you could have just finished, just be joining. You could be at the graduate level as well. So it's not too stringent. So I'll drop. I think you have the Kenya IoT AI Challenge email address. So drop us an email, and I'll send you a booklet on the challenge to give you an idea about it and the different approaches as well. Yeah. I don't know. Is that okay? That help?
Yeah,
All right, great. Yeah, so you can just drop us a message. I hope you all got, for the teams, you got the WhatsApp group invite, so you can also join the group so that any updates could be sent to you even faster. We'll open it up so you can also be able to ask questions as well. And we can be able to, just keep moving along from there. So I'd like to thank you all very, very much for today's session, for making time to be here. And I would also want to especially thank IEEE and Ms. Elizabeth Moshuma for that wonderful session. I think where everyone was present, it was concise, it was effective, it was insightful and interesting as well. So thank you very much for presenting it in a very practical way. So we really appreciate it. So yeah, we'll also share the presentation with the teams as soon as you're able to share it with us. And then in case any teams need advice or help, you could also let us know. We can share your email address, and they can be able to also share some questions that they might also have. I don't know, is that all right?
Yes, Trevor, that's fine. I'll include my contacts in the presentation deck.
Perfect.
Pleasure as well being in this meeting. Over.
Perfect.
All the best to all the participants.